Just now, China has released a new set of breathtaking high-resolution images of the interstellar comet known as 3I Atlas, and the entire astronomy community is once again on edge. Captured by China's Tianwen-1 Mars probe, these images have revealed something extraordinary, something no one expected to see. 3I Atlas is brighter, sharper, and seemingly more active than ever before. And according to early analysis, its movement is changing in ways that suggest it may be coming closer to the inner solar system, possibly even toward Earth. From its orbit around Mars, Tianwen-1's powerful camera captured a series of mesmerizing frames showing the comet glowing with a faint bluish-green hue, its elongated tail stretching like a blade of light across the cosmic void. But it wasn't just the beauty that shocked scientists. It was the motion, the subtle twists, the sudden accelerations, the unnatural bending of its trajectory. The comet wasn't following existing models. It wasn't behaving like an object governed only by gravity and solar wind. Something unseen was nudging it, pulling it, or guiding it along a path that made no sense. Some experts suggested a gravitational anomaly. Others whispered about chemical reactions inside the nucleus, strange reactions that might be releasing bursts of energy. But those explanations sounded fragmentary, incomplete. A comet doesn't simply accelerate for no reason. A comet doesn't change direction in the cold emptiness of space like a living thing responding to its surroundings. Only days after China's release, Earth-based astronomers from the Virtual Telescope project pointed their instruments at the mysterious visitor. Their data confirmed the Mars probe's findings, and added something far stranger. 3I Atlas wasn't just bright. It was pulsing. Its light flickered in repeating intervals, rising and fading like a heartbeat in the darkness. According to Dr. Gianluca Masi, who leads the project, the comet's erratic brightness patterns suggested something powerful was happening deep inside it, something reactive, something dynamic, perhaps something intelligent. And then came the first major shock. Harvard astrophysicist Dr. Avi Loeb, known globally for his controversial but groundbreaking theories on interstellar visitors, gave a statement that sent ripples through the scientific community. He suggested that 3I Atlas might not be a typical comet at all. Its sudden bursts of acceleration mirrored behaviors once theorized for interstellar probes, objects engineered to travel across impossible distances by harnessing sunlight or unknown physics. He wasn't saying 3I Atlas was artificial, but he wasn't ruling it out either. Suddenly, the puzzle pieces began to shift. Scientists went back to older images from the Virtual Telescope project taken months earlier, back when 3I Atlas was nothing more than a dim flicker beyond Neptune. Those faint distortions, once dismissed as camera noise, now matched the exact pulse frequency seen in the new Mars images. The comet had been broadcasting, if that's the right word, long before anyone knew what it was. But the mystery deepened. In one of Tianwen-1's latest image sequences, researchers noticed a faint disc-shaped shadow trailing just behind the comet's glowing core. Too symmetrical for dust. Too consistent for a random plume. Some scientists called it a detached fragment. Others dared to ask, was it a companion object? A smaller body gravitationally bound to the comet, or something else entirely? Something that had been traveling with it across light years? As if the universe wanted to complicate things further, spectral analysis revealed something bizarre. 3I Atlas contained unusually high concentrations of cyanogen gas and long carbon chains, compounds that glow brilliantly green when energized by sunlight. But these molecules are unstable. They should have been breaking apart as the comet approached the sun. Instead, the comet grew brighter. Stronger. Almost as if something inside it was generating energy, replenishing it. China's National Space Administration released a detailed report explaining how Tianwen-1 had observed the comet while Mars passed beneath its faint shadow. During that same window, Earth-based telescopes recorded identical brightness pulses. Perfectly synchronized, once adjusted for light travel time. Two planets watching the same cosmic heartbeat. Coincidence? Maybe. But as Dr. Loeb famously said, coincidence is the word we use when we don't yet understand the cause. Computer models began showing something even stranger. 3I Atlas wasn't just drifting. It was moving in a pattern, an acceleration curve that, when plotted, formed a geometric spiral. A repeating motion. A structure. When astronomers converted the comet's brightness pattern into audio frequencies, the flickers produced a low, rhythmic hum. Some called it noise. Others called it harmonic. But online, it gained a poetic name, the Song of 3I Atlas. As scientists tried to understand the spiraling motion, the pulses, and the green glow, new questions emerged. Could the comet be a fragment of something older, something created in a star system long gone? Could it hold information encoded in its layers of ice and dust? Could the pulses be a natural but complex pattern we've never seen? The days following China's release of the 3I Atlas images have been nothing short of explosive. Across observatories, laboratories, and online scientific forums, theories are erupting at a pace not seen since the discovery of Oumuamua. But this time feels different. This time, the data isn't fading. It's increasing. And the comet is getting closer. As new images streamed in from both Mars and Earth, scientists noticed something unprecedented. The comet's pulse wasn't just a flicker of brightness. It was synchronized with solar activity. Every time the sun released a flare or a burst of radiation, 3I Atlas responded almost instantly, brightening or shifting its tail by a measurable degree. It behaved as though it were reacting to the sun in real time, like a sensor or a living organism responding to a stimulus. Even stranger, the timing between Mars and Earth observations matched perfectly. This meant the comet's reactions weren't random bursts of light. They were consistent signals that crossed millions of kilometers in lockstep. The question haunting everyone: how could a natural object respond with such precision? Tianwen-1's magnetometer added a disturbing new layer. During the comet's pass near Mars, the probe recorded a faint repeating magnetic signature. A pulse. Identical in timing to the brightness variations recorded by Earth's telescopes. Two different instruments. Two different planets. The same repeating pattern. Scientists began wondering if 3I Atlas was generating its own magnetic resonance. Comets don't do that. Not like this. Not with this consistency. Suddenly, the discussions took a dramatic turn. Were these patterns natural? Or were they evidence of a mechanism, some internal process we can't yet identify? If the comet was once part of a larger object, a shattered structure drifting through interstellar space, could that structure have once contained technology? Or physics beyond our understanding? As the debate intensified, computer simulations produced more unsettling results. When the comet's acceleration was plotted across time, the shape wasn't random. It formed a smooth spiral curve, a repeating geometry that suggested something deep inside the comet was controlling the transfer of energy. Not intelligently, necessarily. But systematically. Mechanically. Like resonance. Like feedback. Like a machine trying to stabilize itself. Earth-based astronomers studying its tail discovered that its shape wasn't consistent with solar wind alone. The tail was bending in patterns that suggested an external influence, possibly magnetic fields, possibly plasma currents, or something else entirely. something unknown. And then came a breakthrough. Virtual telescope project scientists noticed that the twin tails of the comet were too symmetrical. Tails are messy, chaotic. They bend, scatter, and twist. But 3I Atlas's tails ran parallel. Sharp. Clean. As if held in place by an invisible structure. Some compared it to magnetic confinement, the kind seen in fusion reactors. A natural comet shouldn't look like this. But 3I Atlas wasn't playing by natural rules. The comet's latest data brought everything to a boiling point. Its core wasn't dimming as expected. It was intensifying. And inside the light curve analysis, researchers discovered harmonic overtones, layers of frequencies embedded inside the primary pulse. These weren't like solar wind effects. They looked patterned. Structured. Theories exploded. Some said this was a chemical engine deep within the comet, reacting, igniting, expanding as it approached the sun. Others suggested a natural electromagnetic resonance caused by the comet's unusual material. But a small group of scientists dared to propose something far more controversial. What if the comet was a remnant of a structure created millions of years ago? Not functioning. Not active. But still carrying the resonant patterns of whatever built it. Like a broken bell still ringing faintly long after the strike. As all this unfolded, projections began showing something astonishing. 3I Atlas's path would bring it extremely close to Earth's orbital region in the coming months. Not a collision, but a close pass, close enough for direct radar imaging. Close enough for probes to be redirected toward it. Close enough that the entire world would look up and see the emerald glow with their own eyes. And if that happens, humanity may finally learn what 3I Atlas really is. A strange comet from the deep dark between stars? A relic of a forgotten solar system? A shattered fragment of something older than human history? Or something more, something that remembers? For now, all we can do is watch as the green light grows brighter, the pulses grow stronger, and the mysterious traveler continues its silent journey toward